Hello, everyone.
Hey there.
Hey, John, where are you?
Must be must be
There he is.
9:30 somewhere.
Yeah, it's 9:30 somewhere. Well, everyone, welcome to. Oh, he's in the glot. John is it?
John, are you there?
I'm here.
So we're having a little bit of internet problem up
Yeah,
here,
we are.
folks.
We're
We've
getting
got
some weird
about
echo.
150 people, and they're all trying to use our Wi-Fi at the same time. So, Rick, maybe if you can take off your background, and maybe
Yep,
you
I'm gonna
too,
do
Rich, that
that
might
too. Whoop,
kind of
I'm gonna get the
reduce
right
the.
one. There it is.
There you go.
There we
Yeah,
go. All right, got Nellie back there.
All right, so I need
yeah,
everybody to be quiet for a second because we have a weird echo. All right, all right, it's not coming from me. All right,
I'm not
Rick.
hearing. I'm not hearing an echo at all.
Yeah. Okay, let me mute mine.
Okay, no, you're fine. All right, look, it looks like we're better now.
yeah. Rich, you might want to take your background down too, just to reduce the bandwidth usage here.
All right. All right. Well, welcome to. You know what, Gerald? I'm going to ask you to do the introduction because I've got this terrible echo and I haven't figured it
Okay.
out.
Yeah. Okay. So, welcome to Chabot Space and Science Center's virtual telescope program for Saturday night, June 26th. We're coming to you from the inside the observatory here at the Chabot Space and Science Center up in the Oakland Hills. Unfortunately, it is completely foggy outside, so we are not able to use our telescope tonight. So we're going to have to do a virtual program. We want to remind everybody that Chabot Space and Science Center is still closed to the public. So we are not doing our normal weekend public viewing through our telescopes. However, we are still doing a few very small rental events up here, and we're doing a lot of work inside of our facility to upgrade the exhibit areas and develop new programming and so forth. So we because we don't have people at the gate, we're not getting the revenue we would normally get from that. So we are relying a lot more these days on donations. So if you're on Facebook and you got a second here, click on that donate button that you see somewhere on the page. There should be a donate button and help us out.
Well,
If
I
you're
have
not
to I
on
have to
Facebook,
interrupt for a second. We've got a vicious rumor started by John that the donate button is fleeting tonight. So
Oh,
if you're having
um,
problems finding the donate button, please visit chabotspace.org, and there will be instructions on the
right.
Chabot website on how to make a donation.
Or at the top, if you click the overview button, that seems to bring our donate button back again. So, not sure what's going on there.
Okay. Yeah, the joys of Facebook. so, so, so I think everything's working now, Richard.
Yeah. I figured out what the echo was being caused by, so I'm no longer echoing.
that's good.
All right. Well, so as Gerald said, we're fogged in tonight pretty heavily. So we're bringing you news from the universe. And but before we get to the universe in general, I think it would be a good idea to talk about an interesting event we've got coming up next Wednesday night, and it's Asteroid Day.
Right.
And we have a program starting at 7 o'clock that's going to be talking about several different aspects of asteroids and asteroid observing. And Gerald, we have an astronaut joining us for that as well, or at least a taped presentation from one of the former space shuttle astronauts. And maybe you could talk about that a little bit. And
Yeah, it's Dr. Ed Lieu. Dr. Ed Lieu is a former astronaut, And he is also with the B612 Foundation, which is a organization composed of a lot of astronauts and cosmonauts. Russian cosmonauts are in it also. And it is dedicated to asteroid research, asteroid tracking, and so forth. Ed Lieu is head of the Asteroid Institute, which is a function within the B612 Foundation. So he is going to be interviewed, I believe, by our Galaxy Explorers, our teenage group here at the Chabot Space and Science Center. And then after that, we will also have Thomas Prettyman, who is a planetary scientist, and he's going to talk a little bit about asteroids. And then I'm going to demonstrate how we use the telescope here at Chabot to actually track near-Earth asteroids. Chabot Space and Science Center is part of a global network of observatories that searches for and tracks near-Earth asteroids. And this telescope right behind me is part of that program. So we're going to demonstrate a little bit about how we do that. So interesting program. And again, it will start at 7 o'clock Pacific Daylight Time on Wednesday, June 30th.
Great. Well, I hope some of you can make it. So we have Rick Taft here tonight, and he's going to show us the results of some experimentation that we did last week. I just want to mention that, we get up here about 8:30, and we get set up for doing the presentation to all of you, and we don't usually have a lot of time to experiment with cameras and other things, but last week Rick hooked up his astronomical DSLR to the telescope, and we were attempting to do different exposure times for different types of astronomical objects in order to figure out what kind of exposures we need for the upcoming summer nebula that are so popular for us to be able to put the telescopes on. And Rick came up with some pretty good results. I'm going to go ahead and share my screen here and let Rick talk about what we did. Bear with me here. There we go. All right.
There it is. Excellent. Thanks, Rich.
Sure.
Well, what you're looking at is the top of the Crescent Nebula. It's actually the northeastern portion of the nebula. The nebula itself is a very pronounced arc, and it's actually caused by a star which is just out of the field of view. I don't know if you can see my mouse cursor, but the star that is responsible for that nebula is just right down here at the bottom of the page.
Is it on the lower left?
No, it's not. It's not in the field of view.
I see.
If the two bright stars, if you were to make like an equilateral triangle out of those stars, that's where you would find the star.
Got it. And so it's like somewhere down here below.
Yes, it would be off the bottom of the screen.
So it's where my Microsoft Word icon is.
That's exactly where it is, Rich. Yes, everyone. Does everyone see that? Yes.
Yeah.
So I'll tell you a little how we came to image this nebula. So last week we were using the camera, and we had it on a variety of objects. I think we looked at the Hercules cluster, and we looked at the blinking snowball or something to that effect. And after we had concluded the program for the evening, I asked the guys, could we swing the telescope around to something that was rich in hydrogen? And that beautiful red color of the nebula right here, this is due to the ionization of hydrogen by more than likely very intense ultraviolet radiation. So we happened to, actually they gave me about 10 minutes, maybe 11 minutes to do this. So this was a really quick aim the telescope and start imaging. And when I got home, this is what I was able to produce from that. And this image is the culmination of only about, I think there were 12 or 14 60-second images, so about 14 or 15 minutes total integration time. And
the notes you sent me said 17, but
is
whatever.
it 17?
Yeah.
Well, we have 17 minutes of total integration time. And, that sounds like a lot of time, but actually to image such a very dim, diffuse object like the Crescent Nebula, it's pretty amazing to capture this much signal in that brief period of time. What's interesting...
So, Rick, if you exceeded your 11-minute time limit and did 17 minutes, you owe us some money.
Well, actually, what happened was, I can tell you guys this. Gerald stepped out. You guys had bailed already, and Gerald and I were here, and he stepped out for a minute, and that was my opportunity to get another 4 or 5 minutes in. So I had promised I would only do 10 minutes, but I was able to apparently get 17, which was good. And so the nebula itself is huge. It's a very large object, and again, all you're seeing is probably a third, maybe even a quarter of the nebula, and then even then, it's only the top portion, northeastern portion of it. So if we have clear skies in the coming weeks, we'll try to image it and get the whole object in. But at least you have an idea of what that nebula looks like. And by the way, the nebula is about 4,700 light years away in the constellation of Cygnus the Swan. And the nebula itself is about 20 to 25 light years across. So that'll give you some idea of what you're looking at there. One of the things that I really enjoy about this image is that the Crescent Nebula is almost dab smack in the middle of the Milky Way. And that's why you see such a large number of stars scattered throughout the frame. And what I really enjoy about this frame are the number of the colors of the stars. And the colors of the stars give us some idea as to the classification of the star, the orange and the red stars, the temperature.
Yep.
Yeah, Gerald, if you'd like to chat about that, feel free to take that away.
Yeah, the color of stars tells us the temperature. Stars that are bluish white are very hot stars. Stars that are white are a little bit cooler. Yellow stars are cooler still. Orange stars are cooler than that. And then the red ones are the coolest stars of all. And by that, I mean, not that they, they're really cool guys, but they're actually cooler in temperature. And if you look carefully, you'll see the red stars outnumber everything else. So there's a lot of relatively cool stars out there.
Yeah, and actually, I'll just say one other thing about the image. I was using a specially modified camera that is about 4 times more sensitive in picking up those deep red colors of hydrogen than a normal DSLR camera. But in addition to that, I tried a new filter that night that eliminated some of the light pollution that we're dealing with here in Oakland. And so I think that filter is a pretty good asset, and one that we'll be using more in the future.
Was that an Optolong filter?
Yeah, it was the Optolong L Pro, and it actually has 4 distinct transmission bands, and it has 2 really deep, rather sharp but deep notches that happen to coincide with the wavelengths of sodium vapor lights, which we see a lot, especially in industrial areas, and other forms of light pollution. It's not very effective against the newer LED type lights, but
that's the problem.
It does help. It does help.
One thing I wanted to clarify, Rick, you said this is right in the middle of the Milky Way. It's right in the middle of the Milky Way as viewed from Earth. It's not right in the middle of the Milky Way, though. It's actually out about halfway out from the central bulge out to the disk. So if you're outside of the Milky Way looking for this thing, you don't look in the middle of the Milky Way. You look.
Yeah, because if it was in the middle of the Milky Way, we wouldn't see it because we'd be inside the black hole.
See, right. I knew I couldn't get away with saying something about this without the critique by the other.
No, we don't get away with that here.
And this will definitely help all those people that are outside the Milky Way.
Let me rephrase this. From my point of view, from my vantage point here on Earth, looking up towards Cygnus, looking up towards the Milky Way, it looks like it's kind of in the Milky Way. There's a lot of stars there, but I concede the point.
Yeah.
Yeah, you got to watch out for that critique.
Oh man.
Yeah, you know, Rick.
And they said I was among friends, but come on.
Yeah, but you know, if we couldn't give you a hard time, we couldn't give you any time at all. So.
Oh boy. All right.
All right.
Very good. All right, let me stop sharing here.
Yeah.
Thanks for this, by the way, Rick. This is really
You're
nice.
welcome. It was a lot of fun.
Somebody asked a question, and it's one of our topics tonight. What's going on with the Hubble?
Yeah.
The Hubble's all messed up, and the Hubble is messed up not because it's a telescope, but because it's got a computer. And actually, that has more than
screw
one.
something up, just put a computer on it.
Just put a
right?
computer on it. So basically, the control system for the Hubble Space Telescope consists of a 1980s vintage computer with 3 memory modules and a backup computer as well. So they lost communication with the control system, and they figured, well, it must be one of the memory modules. Good thing we have 3 of them. And they were not able to get any of the 3 memory modules to work with the primary control computer. So the challenge right now is getting the backup computer online, which was last used probably when it was installed and tested. And so you're talking about a 20-year-old computer, or a 40-year-old computer rather, that has not really been used. It's been out in space being bombarded by cosmic rays and whatnot. And they're trying to get that thing online to replace the one that has failed. And, they certainly built in a lot of redundancy in the system, but the system was never meant to be used this long. So it's going to be a 50-50 proposition. Did I describe that more or less properly, Gerald? Do you have anything to add to that? Because I know you've been following the story.
Yeah, I was just looking at a little write-up on it. The computer, like you say, they have a backup, but before they switch to the backup, they want to make sure they've identified which components precisely has failed, because they want to, when they go to the backup, they want to make sure they're using the right backup system. So there's a couple of different systems within this computer, and it's one of those systems that has failed. So they're trying to make sure that they've correctly identified the failing system before they switch to the backup. The good news is there is a backup, and once they make the final decision on which one they're going to go to, they will be able to get Hubble back up and running. We need to run for at least a couple more years until we get the James Webb Space Telescope up there.
Right, and according to you, we're being optimistic in that regard as well. Mario,
right now the James Webb.
Sorry, go ahead.
Right now the James Webb Space Telescope is scheduled to launch on October 29th, I believe it is. But I've already heard rumors that might slip a little bit. So,
yeah. Well, Mario says that the cause of the problems on the Hubble was that it tried to upgrade itself to Windows 11, and I gotta say, Mario, you were reading our minds, because we spent a full hour before presentation started tonight telling Windows 11 jokes. And he must have overheard us, because here you are with a Windows 11 joke. Let's see, we got some. We cannot send any more mechanics to the Hubble. That will never happen. So they have to figure this one out remotely, and that's why they got to be really careful about eliminating variables before they start switching components around remotely, because you only have one shot at it. All right, so that's our Hubble story. Gerald, you had an interesting experience this week with one of our EAS members, Gert Gottschalk, who is not only a board member of EAS, but he is our director of instruments. He gets involved in repairing our historical telescopes, and in fact spent a lot of time a week ago cleaning the lenses on some of our telescopes. And he was out the other night doing some
Yeah.
astrophotography. He's a fine astrophotographer. And why don't you show us what
he's
he
up,
found?
Okay, well, let me just kind of continue the story here. Gert Gottschalk was up in the hills near Del Valle Reservoir. One of the local astronomy clubs has an observing site there, and he was up there taking images of the region in the constellation Scorpius. Scorpius is a constellation that's low in the southern sky. It's generally in the direction of the center of the Milky Way galaxy, the real center of the Milky Way galaxy.
Wait a minute. Listen, a little later on in the program, I have a picture of the Milky Way that I'll share with you, and it shows that the world is not flat. Well, it's another story.
All right. Okay. So anyway, he was taking these images and he noticed something odd. And so I'm going to share the image here.
You have permission? Oh, yeah. Good.
Hopefully this works. There we go.
Yeah.
Oh.
Okay. So this is the image he was looking at. And I'm going to turn on my slider here for zooming. So this is the star Antares. Antares is a very bright star in the constellation Scorpius. This is M4. It's a globular star cluster in the constellation Scorpius. And there's a lot of dust, gas and dust clouds in the direction of the center of the Milky Way. So you see a lot of that here. And this is an image that he sent me. He sent me this image and he said in his email, he said, can you tell me what the streak is in this thing? Is it possibly an asteroid? And it took me a second to see the streak. You can see
there it
right
is.
here.
Yeah.
All right. And I'm going to zoom in a little bit on that. All right. So you see the streak right here. So he wanted to know if that was an asteroid. Well, as we mentioned earlier, our telescope here at Chabot Space and Science Center is part of a global network of observatories that searches for and tracks near-Earth asteroids. I'm the one that does most of that work with this telescope. So I have a lot of resources for finding out whether or not this was an asteroid. So the first thing I did was I went to a standard catalog that we have of all asteroids that have been identified up to about 4 or 5 days ago. We find about 1,000 of them every year. So I went to that catalog, nothing there. I then went to the catalog of asteroids still needing confirmation. I saw nothing there. So it seemed like, at least in terms of known or probable asteroids, this was not an asteroid. But that still doesn't mean it's not an asteroid. It's possible that Gert had actually discovered a new near-Earth asteroid. So one of the things I did is I looked at the length of this image. His images were 5-minute exposures. And by using some software to identify the image or the stars in this image and to scale the image, I was able to figure out how fast this object, whatever it is, was moving across the sky. That gave me some indication of about how far away it was. It would have been maybe just a little bit closer than the distance to the moon, so somewhere around 250 to 300,000 kilometers away from the Earth. And so, again, maybe it's an asteroid, a newly discovered asteroid. But then I noticed something else about it. I'm going to zoom in a little bit.
Yeah, you got to zoom in a lot
more
more here. So especially for our phone viewers.
Yeah.
There you go.
Yeah. So if you look at this streak, you notice that there's a pattern to it. Mm-hmm. Bright, dim, bright, dim, bright, dim, and so forth. And when you count the number of those, and given the amount of time that this image was taken, you realize you've got something here that's tumbling. Mm-hmm. It's tumbling in such a way that sometimes it reflects more sunlight, sometimes it reflects less sunlight, and it's tumbling at a pretty rapid rate, more than 3 times a minute. Well, asteroids tumble, but they don't tumble that fast. So given that information and its proximity, I concluded that this was not an asteroid. This is actually a piece of space junk. So a lot of times when we launch spacecraft, especially if we launch them into interplanetary missions or to the moon, the upper stages of those launch vehicles end up flying around out in space. And sometimes they go into highly elliptical orbits around the Earth, or they can actually go into orbit around the sun, but periodically come back around and pass by the Earth. And so that's what this object turned out to be. It's not an asteroid. It is a piece of space junk that is tumbling as it flies by us at a distance of somewhere around 250 to 300,000 kilometers. So that's the kind of the analysis process that we go to. This is not unusual. A lot of times when we're out there searching for asteroids, we find something like this and we initially think, aha, I've discovered a new one, only to later realize all we've discovered is another piece of space junk flying around out there.
Yeah.
All right.
I love the train of deduction here. I think it's a really great example.
Yeah.
So I'm going to share the image that Gert was actually trying to produce. Give me a second here because it's worth showing, and especially since it's at his expense that we've got all of this going on tonight. I figure we should show at least the image he was trying to get. Here we go. Share screen. There we go. And it's actually quite a
yes.
beautiful image. And he took this using an ASI CMOS camera hooked up to a 200 millimeter camera lens. And it wasn't using a telescope. It was a camera lens with a astronomical camera attached to it. And beautiful colors. And that's just a very nice result.
So I think
you can really see the dust and the gas and dust here.
Mm-hmm.
When you look toward the center of the Milky Way, you see a lot of big clouds of gas and dust. That is where new stars are forming. In fact, I think I can see a couple of examples of stellar nurseries. Those bright bluish regions, those are young stars that have formed out of those clouds of gas and dust.
Right around there and a little bit over here and definitely over here as well.
So I think we're looking at a mix of reflection nebula and emission nebula, and around Antares.
Exactly right.
Around Antares, you have this beautiful color due to the temperature of that star, and now is Rho Ophiuchus is I'm not sure if that's in this frame, but it's in that same general vicinity, isn't it? Or the Rho, because that is it also. It's a beautiful
Ophiuchus.
Yes,
it's a little bit higher.
I think it's a little higher out of the frame.
Out here.
If that's Antares. It could be couldn't be that far. Yeah.
Yeah, but it is a beautiful nebula,
and these dark areas that you see that are really stand out. These are caused by clouds of dust obscuring the bright regions behind it, right? So it's not like there's a hole in the nebula that you're looking through. It's just dark material that is blocking more of the same. And that's very, very common as you look towards the center of the Milky Way galaxy. You see many of these vast dark regions that are caused by dense clouds of molecular hydrogen. It's basically cold hydrogen gas.
Yeah, this is on my bucket list of celestial objects to image, and one of these days.
Yeah.
Hey, we have a question from Megan. This goes back to Hubble. When the Hubble is decommissioned, will it drift out into space, or is there a plan to get it back to Earth? Probably not.
Unfortunately, there is a plan to bring it back to Earth, but
not in one piece.
Not in one piece. Yeah. It's actually going to. they're going to still operate it for a long time, even with some of the problems it's had. It can still operate, and so it's going to be a while. But eventually, it will be decommissioned and deorbited, and that means it will burn up in the atmosphere. So,
as much as we'd all
unless
love
you
to get
have
a
a way
hold
of
of that
getting up
mirror,
there, get a hold of that 2.4-meter mirror, and
yeah.
have a new telescope here on Earth. It's going to be bad news.
Yeah. Good question, though.
All right. What else we got to show tonight?
Well, I can share an image of the Milky Way that I'm working on. I think if you want to see it.
Sure.
Let me see if I can share. So
somebody asked what is the age of the baby stars that we were talking about in that image earlier. Those stars are probably the ones that are bright bluish. Those are probably less than 1,000,000 years old, which is very young for stars. But blue stars, they're very hot. They're very massive. Massive stars just don't last very long. They only last a few million years, unlike our sun, which is going to last another 5 billion years or more.
But once you have those dense molecular clouds, stars just form from them. I mean, it is the natural progression of having dense gas floating around in space. Those areas will turn into stellar nurseries. In fact, there was a research project that reached its conclusions this week that that basically said when the Big Bang happened, some 13.8 billion years ago, that stars started forming only 250 million years after that event. So you have the Big Bang, you had hydrogen, that hydrogen coalesced into clouds and immediately started forming stars.
So you guys
That's it.
All right. So you're seeing the Milky Way.
Yep.
And the area that we were just looking at would be somewhere, actually, that's Antares right there where the cursor is. So we were just looking at this area right here. And what you're looking at right here is a panoramic view of our Milky Way. And this image stretches about 170 degrees from one side to the other. That's why we're able to see the arch of the Milky Way. I imaged this just last week up at Mount Shasta, and this is still a work in progress, but you can see Mount Shasta with the snow cap, and fortunately we had very little wind when we were there, and we were had set up across from a pond, and we were able to image Mount Shasta with the reflection in the water and the Milky Way. Now you might ask, how are we able to photograph the mountain and the trees? See the pine trees and green? Well, we did this under moonlight. And so this actually, we had a moon that was, I think, at about 30 to 35% illumination. And we planned for that, and we photographed this image. This is not a single exposure, but it's actually made up of 40 individual exposures and then stitched together to form this panoramic image.
Nice work.
Thanks.
Oh, very nice.
Yeah, that's great. I'm not used to seeing Mount Shasta so bare.
Well, that's
very little snow on it.
Anything you've heard about the drought in California is absolutely true. As I drove across the Lake Shasta, the water level is down incredibly low. I mean, there's so much of the exposed sides of the lake visible. But Mount Shasta, there is very little snow on that mountain, and it should be full of snow at this early month in summer here.
Yep.
So we're in for a drought.
Oh, yeah.
All right. Well, why don't we see if we've got any questions from our visitors tonight? I'm going to have to refresh my screen. Bear with me.
I'm not seeing a whole lot of questions.
No, I'm not either.
Yeah. Yeah. Don't be bashful, folks. We are glad to answer any questions that you have. Anything about space, astronomy, star formation,
And don't wait till the last minute.
stock recommendation.
Yeah, stock recommendations. Right.
Yeah.
Yeah. And Windows 11.
Right. Now you've asked for it.
Yeah.
Yeah, really.
Yeah, I'm not seeing.
I see we made
My screen
Stephanie-
refresh isn't
Bob
working very well.
asked
Yeah, mine
about an
didn't either.
Oort comet. There was a new one found. You know anything about that, Joe?
Oh
Yeah.
yeah. Oh yeah.
Go for it,
Yeah,
Gerald. I've been reading
yeah.
about that all week.
So there is a comet that was discovered. It was actually
Uh-oh.
Second. Lost Rick too. Are you? Yeah.
Oh, really?
Rick's there.
No, I'm still there.
Gerald, you're back now. So
I
start
lost
again.
all of you for a few seconds there.
We had an internet hiccup.
Yeah.
we're going to have a new rule during these rental events. And I
Right.
can't use Wi-Fi. Okay. So anyway,
Limit.
this is not a new.
Oh no. Here we go again.
Out again.
Yeah.
We're able to use up time this way, right?
Yeah.
Right.
And can you hear me now?
Okay,
Now we
yeah,
can.
now we
Now
can-
we
again.
can hear you.
Okay. One
So
more time.
apparently the internet connection here doesn't want to know anything about comets.
Yeah.
Right.
So this is a comet that is in a highly elliptical orbit. It goes way out there. Can you hear me?
Yes.
Yes.
Oh, good.
We can hear you.
All right. So it goes way out there, like 8,000 astronomical units. Now, an astronomical unit is the average distance between the Earth and the Sun. It's about 9.
Uh-oh. Stopped again. About 93 million miles. We seem to
Yeah.
be losing
Again.
them.
Internet.
Right. I'm going to turn off this tablet.
Yeah, that's right. But now we can measure the droppage by individual
Yeah.
devices. Yeah. All right, you're back, Gerald.
All right. All right. One more time. So this object is in an orbit that takes it way out very far from the sun. 8,000 astronomical units. Astronomical unit is the average distance between the Earth and the sun. And so it goes out 8,000 times that distance. So way beyond Pluto, way beyond the Kuiper Belt, well out into a region called the Oort cloud. The Oort cloud is a kind of a shell of icy bodies that completely surrounds the solar system. And this is obviously one of those icy bodies. Something perturbed it so that instead of staying in orbit out in the Oort cloud, it has now come in toward the sun, but it's not going to get real close to the sun. In fact, it won't even get as close as the planet Jupiter. But what's unusual about it is how big it is. It is at least 100 kilometers in size, which is really big for a comet. A typical comet might be 2 or 3 kilometers in size. This thing is at least 100 kilometers in diameter. So it's getting a lot of attention in the astronomy community because of its large size. It makes it relatively easy to track. It has come in. It's now relatively close. I believe it's right now about 15 astronomical units away from the sun. It will get even closer, but nowhere near the Earth. It's like I say, it won't get any closer than the planet Jupiter. So that's, if you're hearing a lot about a new comet in the sky and wondering why can't I see it, it's because even though it's very large, it's so far away, you're not going to be able to see it with your naked eye.
Now, they were able to detect it because it's already started outgassing.
Correct. Well, they were able to detect the outgassing. When it was discovered, there was no outgassing going on. Discovered back in 2017, I believe.
Oh, I didn't realize that.
And it's just that recently it started to outgas. That got some people's attention, and then they started looking at it and said, "Holy mackerel, this thing is huge!"
So it's going to reach its closest approach in, like, what was it, 2031? Something like that.
Yeah, it's 2031 or 2032. I can't remember which one it is.
So you got a little bit of time,
and it still won't be very close.
Right. That's right.
Right.
But it's big, so maybe we'll be able to see it through a telescope.
Well, definitely we can image it with this telescope, although it will still look like just a bright dot moving among the stars.
That's okay.
If we ever get a night when it's not foggy and the humidity is not real high, we'll actually take a stab at getting some imagery of it.
All right. There was a question from Mark. There have been a lot of papers on discoveries of underground bodies of water on Mars near the polar regions. Is this accurate, or are there still uncertainties on whether that is actual water?
It's accurate. There has been several studies and some radar probing and so on that shows pretty conclusively that there is subsurface. It's either ice or water. Some of it looks more like ice. Some of it looks like maybe kind of slushy ice, half ice, half water. Mars used to have an ocean. In fact, nearly half the planet at one time was covered by water. And so, of course, the question has always been, where has the water gone? And the answer is it has gone underground. And we've seen indications of this for years, almost as long as we've had spacecraft orbiting around Mars. We've imaged the sides of craters where one orbital pass, you see it's a nice smooth side of the crater. Next orbital path, you can see looks like something has streamed down the side of the crater. And that tells us that there's been some sort of release of water which runs down the side of the crater. It very quickly evaporates because there's hardly any atmosphere on Mars. So we've had lots of indication that there's underground water on Mars, and just more research seems to bear that out. I believe there's a Chinese rover on Mars right now, and I think that's one of the things that they're trying to do is maybe determine a little bit more whether there's Mars or water underground. Definitely, there's ice up there. We've established that multiple ways. In fact, we know
there is water ice, and that's there's the orbital instruments that are designed to detect water, and they have definitely found water ice.
In fact, there was a Mars lander. I forget the name of it now. This was about 7 or 8 years ago.
Oh, yeah.
The idea was it was going to land on Mars, and then it had one of those scooper things, and it was going to dig down and try to find the ice. And it landed relatively close to the North Pole, not all the way up to the North Pole, but relatively close to the North Pole. And their hope was that with this scooping arm, they could dig down and find, subterranean ice. Well, when it landed, it's got these thrusters underneath, and they're blasting down on the ground, and this thing lands. And they've got a camera on this arm, and they start looking around with the camera, and they point the camera underneath the rover underneath the lander. And what they discover is that the blast from these rocket nozzles blew all the dirt away, and there was a big patch of ice right there. So the ice was literally just an inch or so below the dusty, dirty surface. So mission accomplished. They found the ice.
It didn't have to dig at all.
I want to respond to Stephen's question. Stephen asked, should NASA consider developing a smaller version of the shuttle to service instruments like the Hubble or other satellites? Well, there's a lot of reasons why they wouldn't do that, and the first is that just from a cost standpoint, it's cheaper to build another telescope and send it up than it is to figure out a way to get people into space, which is always much more expensive. But the real issue is what are we trying to achieve with orbital telescopes now? The science has moved past the visual astronomy that the Hubble is most capable of, right? And it is moving now into infrared astronomy, so we could look farther back in time. And that's what the James Webb Telescope is supposed to achieve, because it is sensitive into the infrared spectrum. And so the idea is that we'll have a telescope that operates well enough that we could send it into an orbit far enough away from the Earth and the Earth's light pollution to study the farthest reaches of the universe. And it won't be able to be serviced at all because it's going to be too far away. There is no way to, unless we develop warp drive, we're not going to be able to service the James Webb Telescope. And most of the types of images and science that we've become fond of from the Hubble Space Telescope is now achievable using terrestrial instruments. And we don't see a lot of the stuff coming from the big observatories in Chile and Hawaii. They're mostly doing spectroscopy and other types of astronomical science. But it's very possible for us to come close to the image quality that the Hubble was able to provide with terrestrial telescopes.
Yeah. So somebody asked a question here about the alignment or the lineup of Mars, Venus, the Sun, Mercury, and Jupiter. So one of the things we should explain is that the Earth orbits around the Sun, and that orbit forms what we call a orbital plane. You imagine that it's moving on the flat surface of a tabletop. It's just going around the Sun. That orbital plane we call the ecliptic, and the other planets in the solar system also orbit on or close to the ecliptic, and they orbit in the same direction as the Earth is. So they're all pretty much parallel to each other. The planets don't all orbit at the same speed. Mercury and Venus orbit faster than the Earth. Mars and Jupiter and Saturn and so forth, they orbit slower, but they're all pretty much on the same plane. And this plane, the ecliptic, we can actually imagine it projected onto the night sky. And we're going to find all of the planets on or close to the ecliptic, that line in the sky. Now, because they don't all orbit at the same speed, sometimes they get close together, sometimes they're far apart. And right now, what you have is Mars and Venus on or near the ecliptic in the evening sky, and you have Jupiter and Saturn on the ecliptic in the morning sky. And of course, because the ecliptic is the projection of the Earth's orbit around the Sun is also on the ecliptic. So you've got, in the evening sky, you've got Mars, and you've got Venus, then you've got the Sun, and then you've got Jupiter and Saturn. So, they all line up like that. That's very common. And, we're just fortunate right now. They're all kind of close to the sun. At other times, they will be very far away. In fact, later on this year, Saturn and Jupiter are going to get far enough away from the sun that we can actually see them in the nighttime sky.
Far enough away in angle. You got to be careful about
Yeah.
that.
Yeah,
They
that's
never-
right. Now
they
you're
never
doing
get
the same
close.
thing Rick was doing.
Take my astronomer's license away.
Right.
That's okay. I'm
It's just
driving
an
without a
infraction.
license, so yeah.
It's just an infraction. It's an astronomical infraction.
Okay.
There you go.
It just means I get a higher insurance rate, right?
So Jim asked, do comets eventually deteriorate or evaporate to nothing? And the answer is yes, they do.
Well, actually, they evaporate to become old dead comets. that
All
look
dead
a lot
comets.
like-
Yeah.
that look like asteroids.
They look like asteroids or
Yeah.
or Oumuamua, right?
Yeah. Yeah. So a comet is, we call it a dirty snowball. It's a lot of ice, and embedded in that ice is a lot of dirt, sand, gravel, rock, and so on and so forth. And when the comet gets close to the sun, the ice starts to convert into a gas in a process we call sublimation. It's not like the ice in your kitchen when you drop a piece of ice on the floor in your kitchen and it starts to melt and turns liquid. That doesn't happen in space. The ice goes directly from the solid to the gaseous stage, and we call that sublimation. So what happens is when the comet gets close to the sun, the ice begins to sublimate. That's what produces the tail, but it leaves behind all the rock, or a lot of the rock, and dust and dirt and so on. Eventually that forms a dirty veneer around the ice deeper down. And so the comet eventually will look more like an asteroid rather than like a comet. So, one of the things we like to tell people is that there aren't just asteroids and comets, and they're two separate things. There's a continuum between them, because a lot of asteroids that we see today are actually old, dead comets.
Great.
So we have a question. I heard there was a star-going supernova nearby. Is this true? I certainly hope not.
There wasn't a supernova. There was a nova in Cassiopeia a couple of weeks ago.
Yeah.
And it already got too dim. By the time we had a clear night, it was pretty much too dim to even take a look at. It was already past magnitude 12. But it had brightened up considerably and then dimmed up again. It wasn't a supernova; it was a nova.
But it wasn't nearby either. Quite a distance away.
Well, nearby is relative,
I guess.
Yeah. It wasn't hundreds of thousands of light years away. It was more like tens of thousands of light years away.
Yeah, we wouldn't want one going supernova very much closer than that, actually.
Yeah, that's true.
Yeah, I just wanted to correct myself about something I said a while ago, that comet that everybody's talking about was discovered in 2017. I'm wrong. It was discovered in 2014.
Oh.
So I knew it was a few years back, but it was discovered in 2014 when it was much farther away. But because it was so big, it was easy to see, even back then.
I think it's pretty remarkable they were able to discover it before it was outgassing. I mean, what instrument was used to... I mean, the illumination on it has to be like very little for it to be all the way out in the Oort cloud. But it's big.
Large,
it's 100 kilometers. Yeah.
Yeah, it was not in the Oort cloud at that time. Its orbit, I think it takes something like 260,000 years or something like that, some really huge number to make one orbit around the sun. So it was already inbound when it was discovered back in 2014. So
got it. I see. So it's well on its way. All right.
Michelle asks, just Betelgeuse as a question mark, and I think she must have been talking about the
supernovas. Yeah.
And no, it's not Betelgeuse. That's not likely to be soon.
And if it does happen, I really would prefer that it happens in the winter so we could see it.
Yeah,
Right.
You know. Well, if it happens in the summer, we'll see it in the daytime.
We'll probably see it in the daytime, but it won't be anywhere near as interesting as seeing it in the nighttime. And but it would be just our luck. All right. Well, I think anything on YouTube, John? Or
Nope, not
No,
at the moment.
I don't see anything.
I meant in terms of questions, not. In
Yeah,
terms
I know.
Sorry.
Watching streaming Netflix on YouTube.
Yeah, we're not watching.
We're all on Rick's account streaming Netflix. Yeah, that's right. Yeah. All right. Well, thank you all for joining us, and thank you for putting up with our irreverence.
Yeah,
And,
let me just update
did you have something?
thing.
Okay, go for it.
Go
ahead.
I just looked up this comet's orbital period. It's 5,453,858 years.
Oh my gosh, 5 million?
5,453,853.08 years.
So if you do happen to see it in 2032, don't wait around to
Don't
see
wait
it.
around. No. Cancel that dinner date.
Yeah.
That's see it.
It's your last shot.
All right, everyone. Thank you again. And
don't forget to join us this coming Wednesday
on
night.
Wednesday.
Right?
7 o'clock, Chabot's Space and Science Center YouTube or Facebook page, and we'll do the Asteroid Day event.
And by all means, donate if you can.
Yep.
And thank you for those who have donated, too.
Yes,
I see many people have.
Yeah.
Yep.
And hopefully our internet connection will work better there on Wednesday.
Yeah, I hope so. Anyway, we had fun tonight, and thank you for your questions.
All right.
And we'll see you next time.
All right.